Hello all. In this video, we are going to do some hands-on. We are going to analyze Bangalore house price data using Python. I have shared the Bangalore house price data in the NPTEL platform. You can also get this Bangalore house price data in Kaggle or in Google, in internet somewhere. In some GitHub repository also it is available. So in this notebook I prepared the problem statement is we will use this Bangalore house price data and we will try to approximate or estimate a possible price of any house that are kind of part of the Bangalore, in the vicinity of approximately we will try to estimate a possible price of a possible house. So first we are going to load this bunch of Python packages, and then we are going to call the Bangalore house price data. So the first I will print this data set. It has 9 columns: area type, availability, location, size, society, total square feet, bath, a balcony, and price. I have also provided the description of each column. Area type refers to description of the locality. In fact, I can try this also. So yeah, you can just put so I'll do that beautification later. And location stands for where it is located in the Bangalore. Size stands for BHK or bedrooms, like whether it is a 3 BHK or 2 BHK bed. Society stands for which society looks like there are some NA values. Bath stands for number of bathrooms the apartment or the house has. Balcony is the number of balcony. And price stands for the value of the price in rupees lakhs. Data.shape will give you the shape of the data. It has 13,320 rows and 9 columns. Data.columns will give you all the columns that are there, and data.info will give you basic information about each column. Area type, availability, location, size, society, square feet, these are objects type data. Bath, balcony, price, these are float. Now total square feet cannot be object. If you look into the data, total square feet are numeric. There must be some character that was that came in the data, and that resulted the made it object. We will see how to solve that problem. If we say data.describes, it will give you basic summary of the float variables, which is bath, balcony, and price. So like there are 13,247 instances where the bath variable is available. Average 2.69, minimum 1 bathroom. There are most of the median is 2. Most of the values are here. Most of the apartment or house has 2 bathroom, and maximum 40. There could be very big house or mansions which has a very, and the price is average price is 112 lakhs, and median is 72 lakhs, whereas maximum is 3,600 lakhs, so near about 36 crore. So their data dot null, if there are any null values are there, and if you do sum, then if you see that society has maximum number of null values, and balcony also has quite a few null values. So probably it is better to drop society. And we did some basic searching and we found that in this particular row, total square feet was recorded as 34.46 cube times meter. So it's a weird way of recording. So we may have to drop this recording. And performing group by operation. So if this will be like area types, these are the count of the area types. There are 4 kind of area types: built up area, carpet area, plot area, and super built area. So now super built area 8790 instances belongs to super built area. Majority of the instances belong to super built area. 2000 cases and 2400 cases belongs to plot area or built up area, and there are only 87 cases where it is given as a carpet area. So if you run this, so there are 4 cases of area types. Let us do some visualization. So there is a bar plot for the area type. If you do, we can run this. This is the bathroom has a bar plot. This is the bar plot for the bathroom, and you can see there are about almost 7000 instances had 2 bathroom. So maximum cases there are 2 bathroom. And again, this is a pie chart for area type. And balcony, there are 0, 1, 2, 3. Majority are either have 1 balcony or 2 balcony. There are few cases there are 3 balcony, and quite a few cases there are no balcony. Now if you count, we can count how many null values are there for each predictor. The society, as we found, society has the maximum number of null values, then balcony, followed by bath and size. Price, total square feet, availability, area type does not have any balcony, any null values. We are dropping here area types, society, balcony, and availability, because if you run the area types, if you actually run this, copy this, and so if you do availability, so you will see that there are 81 different type of availability. Most of the availability goes to ready to move, and rest of them are just given a number, a date, without any particular mention. So it is not going to create any help in the model final analysis. And area type is also not going to be available, and society has too many null values. So that's why we are going to drop these cases. And after we drop, we have now 13,320 cases still there. And after dropping these columns, now we have 5 columns. And now if we drop the NAs, we have still 13,246 now cases. Now there is no null value in the data set. So that is a good start to have. So now it's a full data, there is no missing data. Now let us do, may have to do some engineering or data cleaning. So not only data engineering, we have to do some and data cleaning. Okay. Now first, if you run data size, you will see that there are 2 BHK, 3 BHK, 4 BHK cases, and if you run this, okay, so there are 2 BHK and then, okay, maybe there are 6. All right, so this is the data set that we have. Okay, and if we plot the BHK cases, so these are the different type of 1, 2, 3, 4 different kinds of BHKs and their plot. So most of the instances are either 2 BHK house or 3 BHK or 4 BHK houses. There are some 1 BHK and 5 BHK, and then other cases are very rare. So the unique values that we have here, and the BHK versus price box plot, these are like side by side box plot. These are like single value cases, so they just put up a dash kind of thing. Now if we just look into number of unique value in the total square feet, it has 2067, and there are just too many unique values, so that we have to, there are some character values, so we have to first check which are the float and which are the not float. So we can create definition, and then where we have float and so empty data frame, and then okay, let us run this. Hopefully this is fine. So there are quite a few. These are the cases where the total square feet we have NAs, and so these are the, we just created price per total square feet. So price per square feet, how much you are paying for each square feet. And now if you just plot, you can see this on the x-axis we are plotting total square feet versus price, and we are here, we are checking the categorical variable versus numerical variables. How many categorical, how many numerical, those are which are the, so these are the numerical variables, and these two are categorical, location and size. So how many new unique locations we have? So there are 1300 unique locations that we have, and in the 1300 unique location, we count that, and this is the situation. There are quite a few locations where you have only single instances. So if we do that, then there will be a little bit of a problem, because you see there are 1300, about 1300 locations, unique location, and if we create a dummy variable, if we do a one-hot encoding, and if we do create a dummy variable for each location, it will create a dummy variable. And there are instances where you have one-hot encoding, and that will make the solution unreliable. In fact, probably you will not have a solution. You can have a solution, but you will not be able to calculate the standard error. So you need at least 20 locations, 20 instances for each for the locations is solution to estimate. So what we are doing here, we are saying that okay, let us try to figure out which are the locations you have unique less than 20 instances. Okay, these are the locations where you have less than 20 instances. Okay, and let's drop those, and we are discarding those locations. So there are now 144 unique locations. After dropping 20 locations, we have now 144 unique locations. And if you just say data dot shape, still you have 246 instances you have. So this is a good thing. And now we are going to do some plotting scatter chart for 2 BHK and 3 BHK properties. So for example, here in the Rajaji Nagar area, you can give an area name, and for that area you will get a 2 BHK and 3 BHK's price. Or say Whitefield, if you take Whitefield and you give another place, just a minute. So let me just copy this here, and instead of let me just run this. So in the Whitefield, these are the 2 BHK prices, and these are the 3 BHK. The x-axis we plot the total square feet, and on the y-axis we are plotting the price for each cases. Now we are plotting the chart for log scale in the total square feet versus log price. So if you plot that, they are somewhat in the much more linear in terms. And if you just do it for the Whitefield also, so this is already for the Whitefield. Okay, let me do it for Rajaji Nagar then. So this was for the Whitefield. Let me do it for the Rajaji Nagar. All right. Okay, so this is less number of instances that you have. So price per square feet, if you see the price per square feet, okay, this is the minimum actually. Let me just first plot. This is the really high price per square feet, and if you create the minimum of it, then the price per square feet is 267. So the range is very big. That is a bit of a weird, I find. And the histogram that you are plotting here for price per square feet, and then bathroom for histogram. So there are a number of bedrooms. These are the number of bedrooms and number of bathrooms. So these are the cases where you have number of bedroom is 9 and number of bathroom and number of bathroom is more than the number of bedroom. So these are like really big houses with lot of, so these could be mansion or something. These are like really big places. So a really big outlier with all these things. So we can drop this probably. These are not really regular cases for sure. So now we are going to do some one-hot encoding for the location. This is very important. So this gives us one-hot encoding for all the locations, 5 rows for 144 columns. For each columns we get the first 5 rows for all the 144 columns. Okay, and at the end we get the others. Okay, all right, and then concatenating with the data frames together, we have to add them, concatenate them. So we just concatenate with the data frames, and then we have to drop the location, because now we have, for each location we have done the one hot encoding, correct? And we can drop the NAs. Now we take the, from the, we can drop the price, and rest of the will become the X matrix. We can drop the size and drop the price per square feet. So this will be our final X. So total square feet, bathroom, BHK, and the locations. These will be the our thing. So X shape will be 13,200 and 146 columns. So we have so many columns, and yeah, and there is no NA. Okay. Okay. So now we are going to split the data into train and test. So we are going to call train test split. Now if, let me just go on the top. Okay, in the, from the sklearn package, scikit-learn package, model selection module, we imported the train and test split here. Okay, so let us run that, and from there we are importing the linear model, linear regression from the linear model of sklearn. We call it regression, and then we are fitting the regression dot fit. Okay, now so the variance score is 0.45, and then if we just plot the residual errors for train data versus test data, so they somewhat overlap each other, so which is a good news, and then if we just plot this, the model, if we just fit the model, OLS model, so adjusted R square is 61, so 61% can be explained by the data. So the total square fit has a very positive coefficient as the, and looks, these p-value are very small for bathroom and BHK. And then there are locations for which some p-value sometimes are small. For example, there is a baseline, and against the baseline, this Akshaya Nagar has a coefficient which is negative 52, and the p-value is small. So that means it is small enough, and the price that you pay is statistically significantly smaller than the baseline. So we can look for places where it is bit high or bit low. So for example, if you see, this place has a positive coefficient, but the p-value is really not large, and the coefficient confidence interval also contains the 0. So that means it's sort of a baseline, and expected, according to the expected price, you don't really expect much. So if you interestingly, Fraser Town is a place which has coefficient positive. That means for Fraser Town you pay a premium, and looks like p-value is small, and the coefficient confidence interval for the coefficient is also not including 0. So I don't live in Bangalore, so the people of Bangalore can tell me whether it makes sense that Fraser Town has a house price which is a bit expensive. Looks like it is expensive place to be. Let us see how it is. For example, Jigani is a place which has a coefficient value negative 68. That means house price is lower than the expected average prices, and then coefficient is also negative, quite low. KR Puram, Kadugori, these are all places where you have prices to be little on the lower side. Now here is one place, Koromongola. Looks like it's a bit expensive place because the coefficient is positive 47.112. P-value is quite small, and the confidence interval for the coefficient is completely right side of the 0, does not include 0. So the people from Bangalore tell me if Koromongola is a place where housing price is more than expected. At least the model is saying it is a bit expensive place. Okay, there is one place looks really expensive, Rajaji Nagar. The coefficient is very high, 155.1818, and then p-value is really small, and interesting, and the coefficient is completely off. One confidence interval of the coefficient is somewhere between 127 and 182. Guys, this place looks like really expensive. Tell me, I don't live in Bangalore, I'm from Chennai. I teach at Chennai Math Institute, so people from Bangalore can tell me whether this place is really expensive place in terms of house price. Okay, so I think you guys can figure out whether you live in a not so expensive place or not so or really expensive place. All right, now suppose we want to predict price for a place where I will go give location, square feet, bath and BHK, and what would be the price. So this piece of code, this function will give you that price, and if I just say predict, it will give me the 107 lakh. So if it is first phase of JP Nagar, 1000 square feet apartment with 2 BHK, 2 bathroom and 2 BHK, then it will cost you 107 lakh, almost 1 crore 7 lakh rupees expected price. So we can play with, similarly you can take this, say if you go to Rajaji Nagar, I think this was the place which was we found a bit expensive. Let's take Rajaji Nagar. Okay, for the same apartment for 1000 square feet and 2 bathroom 2 BHK, it will cost you 2.4 crore or 241 lakh. It's very expensive place to be. Whereas if you in some other place, maybe Rajarajeshwari Nagar, let's see how this place. You need only 33 lakh rupees to buy an apartment in Rajarajeshwari Nagar. So we can see that, based on the location, the price, same apartment can cost very different. Guys, I have no clue whether these values, what this model is predicting, it does make sense or not. So tell me if this makes sense, you guys, and let me know if it makes sense. Then we will know that okay, these predictive models do work, and that will be really fun. So I'll stop here. Thank you very much. See you in the next video.